Hey, welcome. Welcome to our session, Developing Mobile Augmented Reality Applications with Azure Spatial Anchors. So in this session, we're first going to tell you why you should care about Azure Spatial Anchors, why it's an important technology, and why we need the cloud for that, right? And why you actually want to target mobile AR as well. And then I will tell you a couple of examples, lots of scenarios for consumer as well as enterprise use cases. And Paris will actually explain a little bit about the underlying technology. We will also have a demo. You will later on get the source code on GitHub for a native iOS and Android application. And then Paris will also tell you a little bit about UX best practices. And at the end, we should have time for some Q&A. Paris, please introduce yourself.
Awesome. Hi, everyone. I'm Paris, and I'm an engineer on the Azure Mixed Reality Services team. I specifically work on client side for Azure Spatial Anchors, so I touch the SDK and the developer experience.
Great. Hey, I'm Rene. I'm Director of Global Innovation at Valorem Reply. We're a digital transformation firm, pretty much focused on the Microsoft stack, ranging from Azure, including IoT, M365, also to the intelligent edge, like HoloLens. And we have been doing mixed reality since 2015, being part of the Mixed Reality Partner Program. But even before that, I've been doing a mobile AR. For example, I created an open source project called Slot Toolkit, which is a port of the famous AR Toolkit I did like 9 or 10 years ago. You might also notice the slide says Microsoft Regional Director and MVP. So just to be clear, these are awards that Microsoft provides to independent experts. So I don't work for Microsoft. I just love the technology and being part of the community. And that's amazing because I can be here on stage and talk to you about this interesting technology. And for example, why you should care about mobile AR. Right? Why is mobile AR relevant? If we have devices like the HoloLens 2 with all these amazing sensors, right? Why should we care about mobile AR in the end? Well, let's take a look at some numbers here. Gartner predicts that by next year, 100 million consumers will shop in AR, online as well as retail. And especially for retail experiences, I can imagine a lot of value being added by persisted content that can also be shared across devices, right? And more about that later in a couple of slides. I will show you some scenarios. But also take a look at the right-hand side of that slide. You can see it that data is from Newzoo, an ARM company. And they say in September 2018 that 26% of all active iOS and Android devices supported either ARKit or ARCore, right? These advanced AR SDKs. And by now, it might be fair to say in May 2019, it's probably more than 1/3 of all active iOS and Android devices that have these built-in advanced AR capabilities you can use with spatial anchors, right? So you can do the math yourself, but it's a huge market to tap into, right? So if we have these devices with these advanced AR capabilities built in, why would we use Azure, right? Why does Azure make sense here? Well, all of these devices have a view of the digital world in their own device, right? And so taking it out of just the device view, basically, and merging those together from all the different devices, that can be enabled with the cloud, right? That can be enabled with Azure Spatial Anchors, and you can have this unified view of the digital world. And of course, you can securely store it, which means you can enable these persistent experiences, right? You can store it securely in Azure. And so these devices perceive the real world in a certain way. And a couple of you are pretty much familiar with it, but just to make sure we're all on the same page. So here's a video I recorded with my Android ARCore enabled phone that shows you how it perceives the real world, right? So what you can see here, these blue dots are feature points. And then you can also see these planes, this grid overlay, right? And so that grid overlay, currently ARCore supports surface planes for horizontal and vertical planes. So basically, the device can reconstruct real-world planes, vertical and horizontal. And you can place virtual content on it, like this weird guy that is scanned in 3D. And of course, it works outdoors, right? So you can also scan it outdoors. And so that is the view of my Android device. If I would use now an iOS device or different Android device, they would have a slightly different view of the real world, right? Or take a HoloLens, for example. So here's a similar scene recorded with the HoloLens. And of course, the HoloLens, with having more sensors, it has a more detailed view of the real world, and it can reconstruct its spatial mesh in a little bit more detail. But again, right, it's a digital representation. This is how the device sees the world, and you can bring in content, have it interact with the real world. But what we really want is we want to step out from our local view and step into this global view, right? Having these merged experiences from all different devices, providing cross-platform experiences where we can place content, right? So we can drop virtual content in the real world on these surfaces. And we can also anchor that content there, which means that content will stay at the exact same position. So you might ask, what is a spatial anchor? What is that concept of an anchor? Well, let's talk a little bit about that. An anchor is basically a special point in the real world where the tracking system will make sure that the position and the orientation of that point will stay in relation to the real world. Which means even if you walk around, right, go back, go forward, this anchor will stay at the exact same position, right? So the tracking system then assigns a coordinate system, or that anchor is a coordinate system, and then on that anchor, on that coordinate system, you can attach virtual content to it. Which means if that content is anchored, if that content is related to that anchor, it will make sure it stays at that position, even if you walk around, right? But again, the anchor is really just a location. It's not the content. You can, attach any content to it if you want. So that is a spatial anchor, right? Just local on the device. And HoloLens supports it, ARKit supports it, AR Core, Magic Leap, all of these platforms have a concept of a spatial anchor. They might just call it a little bit differently, but they all have that concept, right? So what is a cloud spatial anchor then? Well, with Azure Spatial Anchors, you can upload these anchors that you created on your device to the Azure Spatial Anchor service, and then you can have your friend, for example, come in, use its own device, download that anchor from the Azure Spatial Anchor service, then it will map that anchor from the Azure Spatial Anchor service into the device's local tracking system, and then, well, it can see the same content at the exact same position, right? So you can enable these kind of shared cross-platform experiences with Azure Spatial Anchors that normalizes these kind of different views, right? And you can persist it, right? So I can come back a week later, content is still there, I can still see it at the exact same position. Pretty hot research topic at the moment, a couple of startups in that space, as well as the big players. But I can tell you, Microsoft with Azure Spatial Anchors is really the only one that provides true persistence, right? They have really a leap forward compared to others in the market. Paris will explain later to you how the data actually looks under the hood, like what is a spatial anchor in terms of data, how the feature points are stored. But I want to go on and show you some tests and some more examples that make that abstract concept a little bit more feasible. All right, so yeah, what I said, right? Download the anchor, and you can see the same data a week later at the exact same spot. All right, so here's a video I recorded with my Android phone as well as a HoloLens. So this is about cross-platform shared experiences. Some of you might have seen it online before, but if not, take a look. Basically, I created that anchor with my Android phone, right? So that is recorded from the Android phone. I create the anchor, upload it to the Azure Spatial Anchor service. Now, this is the first-person view of the HoloLens now, right? So I load that anchor from Azure Spatial Anchor service into the HoloLens, and then I can see the content at the exact same position. So you can see me holding my phone in front. It's really aligned really well. And so when I did these kind of tests, I was really surprised how good the accuracy actually is. It is fantastic. We're talking about centimeter range precision here, right? And again, that is not using any GPS. It's purely based on computer vision. It's purely based on the Azure Spatial Anchor computer vision. If we would use GPS, we would probably get meter range kind of precision, right? And with this, with the computer vision, we can get in the centimeter range of precision. Though you can still combine both, right? It totally makes sense, actually. If you think about, you could use GPS for further narrowing down the search space. So you could say, okay, I'm only interested in all the anchor IDs that are like 100 meters around me. So you can just load those and just search for them later on, right? So it totally makes sense to actually use GPS or Wi-Fi IDs, Wi-Fi fingerprinting, these kind of technologies, and combine it with Azure Spatial Anchors to get to the really detailed matching and the great accuracy. All right, so this is cross-platform shared experiences. Let's take a look at persistence. So some of you might know the famous Pike Place Market in Seattle, just down the street. And so what I did in March during the MVP Summit, I went there and created an Azure Spatial Anchor and saved it, of course. Right, so there's the anchor. And a couple of days later, I went back and relocalized it. And as you can see, voila, it's right there at the exact same position. What you also might be able to notice, the floor pattern changed. Right? When I created the anchor, it was wet. When I relocated the anchor, it dried up. Also, a lot of people moving around, so a lot of dynamic scene changes that are really challenging for the SLAM, for the computer vision under the hood. And I was, again, really surprised how well it works and how good the accuracy actually is. And no GPS, again, right? Just purely computer vision, just pure the power of Azure Spatial Anchors. Okay, so test all done. Let's talk about enterprise scenarios. And like I mentioned, we have been working with enterprises since many years. So what I did here, I extracted some common use cases, which I'm going through now in a couple of different categories. And then we're talking first enterprise, then we're going into consumer scenarios. So let's talk about the first use case category, which is about multi-user shared experiences with persisted content. So as you can see on the photo here, we have these kind of collaborative design reviews. So the lady is running a HoloLens 2, the other people are using different tablets. And the good thing is they can see the same content at the exact same location, even though they use different devices. So the business value here is really that we can visualize these kind of complex 3D data in these cross-functional teams, right? And therefore increase business value, therefore increase cost and quality, because you can, much easier collaborate on that virtual content. Or of course, seeing real-time sensor data on the actual equipment. So you can, for example, have, like here in the photo, a control panel on a sensor and can see the actual sensor data in real time at the actual machinery. If you think about what you need to do now, there's like a complex control room panel. You need to search through all that data and so on. And with that, you can easily look up the data. Just go to the machine, see it right on spot, and of course, get much faster information and save a lot of time. Training guidance. So I'm going to show you a video of an app we did for a client a while ago, which is for an automotive seat assembly. And the challenge there was basically they have quite a bit of turnover rate. So new employees come in, they need to be trained and so on, and they just have a limited amount of trainers on staff. So what we did with that app is basically enabling, empowering the trainees to train these easy steps themselves. So you can see these holographic overlays, right? And so they can learn how to assemble an automotive seat.
There's a risk that the finisher tanks are not aligned.
So you might wonder, how do we actually know where to position the virtual content on top of the real seat, right? Because you see it's really nicely aligned. So what we're using here is a fiducial marker, right? So you can see the marker there highlighted. Some call them AR marker, image target, QR code, whatever, right? But these kind of fiducial marker help us to find a reference point in the real world, and then we know the offset where to actually position the virtual content. So why am I telling you that? Well, with Azure Spatial Anchors, we can get rid of those. We don't need any fiducial markers anymore. Because as if you created some of these fiducial markers before, it can be quite cumbersome, right? You need to add a design, and then you need to print them and test the size and maybe change something and reprint and kind of iterative process. So if we use Azure Spatial Anchors, what we can do, we can just use a phone, go on site and scan the position in the room and then create an anchor, and that will be our reference point, right? We can create this markerless tracking data on the fly and persist it. So we don't have to deal with ugly fiducial markers anymore. And of course, the other benefit is, of course, right? No extra kind of thingy on top of that, which might be annoying for if you think about like automotive or other trade shows where I really don't want to have any stickers attached to anything, right? So that is really, really a big value add, I think. Another category is wayfinding. And Paris will explain to you later on how that actually works under the hood with a graph. But just think about if you create an anchor and then you create actually multiple anchors in the same session, they will be connected with each other, right? So you can have these kind of wayfinding scenarios. Okay, go to this next anchor and so on. So take a look at the photo. That's the Boeing plant up in Everett here. It's a huge facility, and they actually offer a tour. So if you have not been there, I would highly recommend take the tour. It's really, really amazing. But can you imagine it's like your first day on site, and all you get is like this kind of map, and they tell you, yeah, find your colleague in the section PC45 or whatever. I would highly struggle. I would probably have to, interrupt coworkers, ask them where do you need to go, and so on and so forth. Well, with Azure Spatial Anchors, we can create these wayfinding experiences, right? And so they can just pull out the phone and they actually get navigated where they need to go. Save a lot of time, increasing employee productivity. Another business value is, of course, with Azure Spatial Anchors, you can actually securely map your facility in 3D. because it's not storing any photos or stuff, right? It's really just storing a sparse point cloud. Again, Paris will explain that to you much later, but it's really the high benefit is you can securely map your 3D environment. All right, there's another scenario. So think about this one. There's an engineer in the control room, and a certain machine is failing. So they see, like, on the control room panel, like an LED or whatever, right, is blinking. Oh, this machine is failing. So what they need to do now is they need to go through, like, some instructions or some maps to find, okay, or maybe blueprints, right? Where do I need to go? Where's that machine? Where's the sensor? And so on and so forth. Now think about if we would enable them with an app on a phone or a HoloLens, they can just look it up on the control room panel. For example, take their phone, hold it up in front of the control room panel, and then we have some computer vision that recognizes which kind of sensor it is, and then it loads the data from Azure Spatial Anchors and guides the user to the actual machine where it is failing, right? And so getting there much faster will save a lot of money. Because as you probably know, if you're working with enterprises, like certain facilities, if they just shut down for a couple of minutes, it costs hundreds of thousands of dollars. So just saving a couple of minutes or even seconds can be a huge time saver here, right? There's a lot of business potential there. Navigating warehouses, well, that's pretty clear, right? So think about, need to fulfill an order, pick up certain stuff, and we can also provide dynamic information. Go there and, pick that kind of stuff up. And so we can business value, increase efficiency, and also less packaging errors in the end. Cool, let's talk about consumer scenarios, because like I mentioned, there are so many devices out there that are enabled with it, right? Android, AR Core, iPhone, ARKit, HoloLens, and so it's a huge market. And of course, pretty much everyone has a smartphone, and many of them actually support these advanced AR capabilities. So here's the first one. Again, wayfinding. Think about a spatial aware grocery list, right? So you can go to the grocery store and create these anchors at certain locations, at certain aisles with the favorite products. Or for example, when my wife sends me grocery shopping, I always struggle because I don't go that often, right? So I always struggle to find the stuff. So it would be awesome if she would create these anchors and then I just pull out my phone and it tells me, oh, go there, pick this up, go there, pick that up, right? That would save me a lot of time. I would be so happy to have that. Well, take a look at this. This was a couple of days ago. I really got the note on the left side. Then I went into the store and created these anchors. That's, by the way, the demo app you're going to get later. And so you can create these anchors with, like, what you need to buy. Now think about you can actually share that anchor data with the store. So the store can access that if you want, of course. And so they could say, OK, we noticed you buy that product very often. Here's a $2 discount. And they can drop that info. They can drop that at the anchor, right at the position. So for retail, there's a huge, huge potential, I think. Because as we all know, brick-and-mortar stores have been struggling with all the retail competition throughout the last couple of years. But with these advanced AR capabilities and scenarios, we can actually increase foot traffic and bring more people in. And it doesn't have to only be wayfinding. Also think about sampling virtual products, right at the location. For example, you have some modular components, and then you can actually see the real object, and then see some virtual accessories they don't have in stock at the moment, but you can buy later, right? So a lot of these scenarios are possible for retail. We just talked about visual content, right? We just talked about adding visual content to anchors. But like I mentioned initially, an anchor is really just a location in the real world. So we can actually not just attach visual content, but also audio content. So we could, for example, use spatial sound for navigating. So if you're not familiar with spatial sound is basically a way that you as a human, know where sound is coming from in the world, right? So okay, I hear the sound there, I need to go in this direction, right? And so we can use that. We can drop spatial sound at anchors and then empower everyone to navigate. So let me show you a quick video from an app called Seeing Eye. It's a Microsoft internal product. Which was just enhanced with some really nice features. Well, take a look at the video.
Navigate to my next meeting.
Your next meeting is with Juliet in Studio C. Would you like me to guide you?
Yes.
Are you starting from the lobby of Studio C?
Yes.
Pan your phone to map the room. Follow the audio breadcrumbs to conference room 1200.
Where can I sit?
Pan your phone to map the room. Table at 12 o'clock, empty seat located at 11 o'clock.
Hey, glad you're here. Let's get started.
That's pretty awesome, isn't it? So I really love it where I don't take credit for it, right? It's from the Seeing Eye team, but I love what they did there. They're using Azure Spatial Anchors really to empower everyone and for these kind of navigation scenarios. And yeah, love where Microsoft is going with the whole AI for good movement. It's really awesome. Alrighty, let's go on. Finding, think about navigating areas like a museum, theme park, festival, and so on. So here's a video I got from our friends at Studio 05 in the Netherlands, and it's a concept they made for theme park navigation. Again, that's a concept, but they could make it real now with Azure Spatial Anchors, actually. So you have your favorite theme park figure, right? It shows you where you need to go, and it can even pull in dynamic information. So it can, for example, tell you, okay, if you go left, 15-minute waiting times. If you would go right, 30 minutes waiting times, right? Of course, you go left and follow our friend. And yeah, you save a lot of time, and you would be pretty happy, I guess. So yeah, a lot of business value in terms of like engaging customer experiences, right? And oh, by the way, also think about digital content on it, and for 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 example, our good old friend Clippy, right? And you know what? It doesn't have to be Clippy in 2D. We can have Clippy in 3D. All right, but joke aside, think about all these social media apps with the AR filters, right? These are very only an experience for yourself, right? If you use these AR filters, you can create these AR filters, but it's just for yourself. Now, if you think about with Azure Spatial Anchors, you can actually share them with other people and even can persist them, right? And they would work at any location, not just some specific handpicked location as we see these days. And so, and the good thing is you can even have customizable persistence. So you can define the expiration date. You could say, okay, this virtual content dies after a couple of minutes, hours, days, or could be there forever, right? So huge potential for these kind of social engaging applications. Architecture visualization. So this is a photo from Switzerland where they set up these poles they call Baugespann. And these poles basically define how big a building will be before it's being built, right? So then actually neighbors can also come in and oppose against it, right? They see, oh, that's a huge building, I don't want to have that there. And now think about, it's quite a tedious and laborious work to set up these poles, right? Now think about, they would just set them up virtually. Construction company, architect comes on site, sets up these poles as Azure Spatial Anchors, maybe leaves a QR code there, right? Then you can download an app and see that stuff. And it doesn't only have to be these ugly poles. They could actually visualize the real building. They could actually visualize a CAD model of that building, how it will look like when it's actually being built. And so the neighbors might actually not oppose against it, because they don't just like see some poles and imagine in their head, oh, that's a big cube. No, they can actually see it will be a nice building, and so you get much better commitment. And also think about not just the private sector, also think about the public sector. Right? There are sometimes these highly controversial projects like airport expansions, bridges, and that kind of stuff. And in Germany, there's a lot of controversials around that stuff all the time. So having these kind of applications that visualize it on-site and have these persistent experiences can save you a lot of money. And so business value is really here, not just reducing the work of setting up these kind of poles for this specific examples, but if you broaden the range, better visualization means better commitment and in the end, cost saving. Well, marketing and ads, right? That's pretty clear. So here's a video, dropped the Valorem Reply logo, recorded a video, shot it online, had a little bit of win. And yeah, I mean, you can do a lot of engaging customer experiences there. Of course, if we talk about advertisement, we need to think about privacy. Good thing is, it's all safe, it's all private, because Azure Spatial Anchor Service is connected to a tenant, which means everyone can have their own view, their own layer of the virtual world. Right? Points of interest. So here's a video, took my road bike, went out to the place I live. We have some beautiful rocks there, and went up the hill, and then, dropped a spatial anchor there with a point of interest information, so it tells you about this beautiful region. Just text in this case, right? But think about tourist agencies. They cannot just set up text there. They could have really nice, engaging experiences. Could be a video, could be an interactive content. So these kind of really engaging experiences for users. And of course, you can reduce the cost setting up these signs. But I think the even higher value is providing these engaging experiences. And there are so many tourist regions competing all the time. It's like using innovative technology to set yourself apart from the competition. And of course, games. I mean, Azure Spatial Anchors screams games, right? That is perfect for games. So think about hide and seek games, kind of scavenger hunt games, any kind of location-based, social engaging games could be possible with these kind of multi-user cross-platform experiences. And the really, really nice thing, what I love about Azure Spatial Anchors is that it actually democratizes location-based AR game development. Because anyone can build a real Pokemon Go now, basically, right? So here's a video. Went to Bellevue and Redmond, created some anchors all over the place, and then attached some virtual fruits to it and persisted them, so they're still there. Good thing is, no one will slip on a virtual banana. It's safe that I left it there on the sidewalk. Yeah, so, fruity anchors all over the place in Bellevue and Redmond. And yeah, I might come back at some point and develop my fruit hunt game, so I have the basis for that now. Anyway, I hope the last couple of examples gave you some inspiration, sparked some ideas for your own projects. Now, Paris is actually explaining you how you can build these your own.
Awesome. Thank you, Renee. So I'm still waiting for the banana game, but to help everyone build that game, I want to get into a little bit more detail on Azure Spatial Anchors and how you can build apps for it. So to start, let's revisit this diagram, because it's really important that we're all together on what is a spatial anchor and what is a cloud spatial anchor. A spatial anchor, like Renee discussed, is a common frame of reference between the digital and physical world. So you have this spatial anchor, and you can render a hologram there. The spatial anchor is that location, not the rocket ship. If you want to share that location with Azure Spatial Anchors, you can send it up to Azure Spatial Anchors, which I'm going to abbreviate to ASA from now on, sometimes. And when your friend comes, they can get the location sent to them, and then render a hologram there as well. So to give you a little insight onto what's going on here, I want to show you a picture that I know really well, because this is the lobby of my building at work. I want to then show you what Azure Spatial Anchor sees when it looks at that. So in this GIF, there are three main things going on. First, in green, are feature points. Feature points are areas of high visual contrast. They're areas where there was an edge or a corner that went from dark to light, or a place where maybe if you look at your badge, your writing was on it and it went from white to black. We get feature points by passing in camera frames to our algorithms. So what you're seeing here in red are each of the camera frames that a mobile device is passing into Azure Spatial Anchors. Next, in the bottom left, you're seeing a spatial anchor. So that white sphere is a place in the real world that somebody said, I care about this, I'm going to place an anchor here, and so that I can later retrieve it. I want to note that all of the processing that we're doing to go from these camera frames to our feature points is happening on the device, so we're not sending these images up to the cloud. With that in mind, I want to talk about three things now. First, how do you build an app for collaboration? Next, how do we extend that to build a wayfinding app? And then finally, let's talk a little bit about UX when building with ASA. So to start, we're cross-platform. So you can build for HoloLens, iOS, or Android, and you can build in Unity, or you can write native code. In this example, we're mostly going to focus on a Java Android app, but the concepts are pretty universal across all platforms and development environments. So let's show a demo first. Before today, we built an app that was similar to René's factory floor example, where he showed you how by placing notes on a car assembly line, you're able to save money for the business because they can just render that hologram right on the car seat. So I'm now going to switch over, and I'm going to show you an Android app. Before today, I placed a note up here. And what you're going to see is I'm going to open up the app, and we're going to scan around for keyframes. We're going to scan around for feature points from camera frames. So here we are, opening the app, and we're looking for that anchor right now. AR Core is right now looking for a plane, which it just found. And there we go. Hello, world. So we now have an anchor at that place that we found. Let's place a new anchor. So we'll do a smiley face. Right now, Azure Spatial Anchors is getting camera frames and turning them into feature points. We went yellow when we had enough data about the environment to save to Azure Spatial Anchors. And we went blue when the anchor has been successfully saved. So let's imagine a week passes, and we want to find these same two anchors. René is going to come up now, and we're going to show you how, both on this Android device and an iOS device, you can find those same two anchors. So I'm going to open up my app, and René's going to open up his, and there we go. Smiley face and hello world, and René also got it, so live demo worked. Awesome. So let's go back, and let's talk a little bit about how we built this. I'm going to show you a diagram that's our architecture for the app. So there's three main things going on in this diagram. First, we have some client code. So we have an iOS app that we wrote in Swift using ARKit and SceneKit, and we have an Android app in Java using ARCore and SceneForm. Next, we have Azure Spatial Anchors, which is how we're saving anchors and finding them later. And finally, we have what we're calling the sharing service. This isn't actually an Azure service, we're just calling it that. In this case, it's made up of two things. An Azure App Service ASP.NET Web API lets you do post calls, get calls, and Azure Cosmos DB table storage as a database. Together, they help us save information about anchors that we need to save. I will give you more detail on that, but before we do that, I want to jump into some API key concepts for ASA. So at the root of ASA is the Cloud Spatial Anchor session. And first, it provides core services. So through it, you create anchors, locate them, update their properties, or delete them. And second, it captures data about the environment. And when I say that, I mean on mobile devices, you're passing in camera frames to the session, or on HoloLens, we're getting the map from HoloLens and passing it in ourselves. Next, we have the anchor. And the really key thing I want to call out here is that it links to the underlying AR platform anchor. So if you're writing a HoloLens app and you have a world anchor, you set that as a property on the Cloud Spatial Anchor. Or if you're on iOS, you use an AR anchor or Android an anchor. So you don't have to do any conversion math. You just set the anchor that you're used to working with on the platform of your choice as a property on our Cloud Spatial Anchor object. Next, it holds a unique ID, an expiration date, and a bag of properties. When you're ready to create an anchor, and by that I mean you have an anchor and you're ready to save it to the cloud, you're going to call create anchor async on this Cloud Spatial Anchor. In return, we're going to give you a Cloud Spatial Anchor in a callback. The difference between the anchor that you're about to save and the anchor that we give you back is that it has an ID assigned. So when you're just writing your app, you won't have IDs. It's only once you actually save them. When you're ready to locate anchors, so for example, up here, we want to define those two, we're going to use the concept of a watcher. And a watcher is something that looks for anchors that meet the specified criteria. And I promise I'll tell you what criteria are in a second. But when they find anchors that meet the specified criteria, you'll get back those objects through a delegate or a callback. The interesting thing about the anchors that come back is they will have that underlying AR platform assigned as a property. So here you saw we had an iOS app and an Android app. I created an anchor, I created a Cloud Spatial Anchor on Android, and I was able to find it on iOS. When I was on iOS, I was given back that AR anchor, even though I created the Cloud Spatial Anchor with the AR core anchor. So that's the aspect of cross-platform that we talk about, is that we do the conversion between different systems, and you get to work with whatever you want. The criteria that I promised are anchor locate criteria, and it's an array of IDs. So you might be looking at this and saying, okay, I create an anchor, and I get back an ID. Later, when I want to find anchors, I need to give you IDs. So where do I put those IDs? That's why we have the sharing service. The sharing service is just a database of IDs. Because it's not really important what the implementation details are for this talk, we're just going to simplify it and just think of it as a database. It's a database that stores IDs. So what else is going on in here? There's three main things. First, we're initializing a session. Then, we're creating an anchor. And finally, we're locating the anchors. So if we walk through how data is flowing, first, we save the anchor to ASA. In return, we get an ID. We save that ID to the database, and we've created an anchor. When we're ready to locate anchors, we're going to get the IDs from the database, tell them to ASA through the criteria that we set on a watcher, and get back the anchors. In between steps 5 and 6, you're scanning your phone around to get environment data. One thing I want to call out before we move on is that you write this yourself. So in this app that we wrote, we just used the key of build 2019, and that's how we selected the grouping of anchors that we wanted to look for. But you could use other things. You could use GPS to kind of narrow it down to anchors maybe around you, and then you look for those. Or you could use user ID or some other app-specific property. With that preface, I want to show you 4 slides of code that will step you through 1, 2, and 3. And we're going to go forward in my favorite IDE, which is PowerPoint. So here we are in step 1, initializing a session. And we're in onCreate, which is like start in Unity or view load on iOS. To start, we're going to set up our AR core and scene form things. I'm using ellipses here to emit code that you can see on GitHub or you can see in many AR sample apps. But basically, here we have scene view and scene, which are scene form concepts. Next, we're going to initialize the Cloud Spatial Anchor session. First was the session. We're going to set a log level, and we're going to set an account ID and an account key, which you get from Azure.com. After that, we're going to set up the frame listener, or the update listener. And what this does is it gives frames to Azure Spatial Anchors. So in the GIF I showed you, we had the many keyframes or camera frames that were being turned into feature points. This is how we give Azure Spatial Anchors those camera frames. This onUpdate listener is a Java concept. Basically, it will be called every time AR Core has a new camera frame to give us. In return, we're going to call processFrame on that camera frame. So this is one side of the handshake that I'm about to show you. We give camera frames to Azure Spatial Anchors. In return, Azure Spatial Anchors is going to give us back a float that tells us how much information about the environment it has. So we're doing this cloud session.sessionUpdatedListener. This will be called by Azure Spatial Anchors, and it'll tell us when we're ready to create an anchor. Session updated will be a float, and when it gets to 1, that is Azure Spatial Anchors telling you as an app, you can save an anchor, we know about the environment. So here we have this handshake. Give frames to Azure Spatial Anchors. In return, you'll get back a float, 0 to 2. When it gets to 1, you're ready to save an anchor. We'll throw an error if you save an anchor too early because you don't have enough environment information. Now that we've initialized the session, we're ready to create an anchor. Before we can create an anchor, we need to choose a place in the real world to place that anchor. What we're going to do is set this on-tap AR plane listener, which is an AR core concept. What it's going to do is say, whenever the user taps on the phone and it's tapping on a plane, so a horizontal space or vertical space, call this handle tap method, and we get to write the handle tap method ourselves. So let's go in and write that handle tap method, which will let us create an anchor. We're going to get passed in a hit result. And with that hit result, we're going to create an AR core anchor. Creating an AR core anchor is pretty much a raycast down into the real world. So we're going to say hitResult.createAnchor, raycast down from 2D space into 3D space, and we now have our spatial anchor. After that, we can render a white sphere. So you saw how I tapped a place and there was a white sphere for a little bit. That was us just rendering a local AR core anchor. No Azure Spatial Anchors, kind of Java Android concepts. Next, here comes the magic. We're going to create the Cloud Spatial Anchor, and we're going to set the local anchor as that AR core anchor. So here is us setting the underlying AR platform anchor on the Cloud Spatial Anchor. After that, we're going to prompt the user to input a note. So that was the smiley face that I typed in. We're going to then set it as a property on the Cloud Spatial Anchor. So we have a string dictionary, and you can set things that you want on there. Next, we're going to wait until we have enough data about the environment. So when I talked about that handshake, that here's camera frames, give us back a number, we're waiting until we get above 1, so we know enough about the environment. Once we get to there, we can save it to Azure Spatial Anchors. So we're going to save it and wait for a callback. That callback will have the Cloud Spatial Anchor with an ID assigned. We're going to update the sphere color to blue because we successfully saved the anchor. And then we're going to save the ID to the sharing service. So with this, we created an anchor in the real world using AR Core. We saved a Cloud Spatial Anchor to Azure Spatial Anchors, and then we saved that ID to the sharing service. On the other side of things, we're going to locate the anchor, and we're going to start from the sharing service. We're then going to do a get call, and we're going to get this list of identifiers. Like we talked about before, in this case, we're just using a key. You could use GPS or another way to filter down the anchors you're interested in. Once you have the anchor IDs you're interested in, you're going to create a watcher. To create a watcher, you create your criteria, you set the identifiers as that list of identifiers you're interested in, and then you tell Azure Spatial Anchors, cloud session.createWatcher. Now, as you pan your phone around and we get feature points in the real world, we'll be trying to match those feature points to the feature points we've saved that line up with those identifiers. When we find anchors, we need a way to tell you about them. So let's go back to that code we wrote for initializing the session and add something that we forgot. What we're going to add is an anchor located listener. So this is a callback that will get called once we've found an anchor. There are several statuses that can occur here. We're just going to show located. Another option is not located does not exist, and that could come up if you give us a bad identifier that we don't know about. So here we found one, and so we have the locate anchor status of located. Now we're going to get the AR core anchor from that Cloud Spatial Anchor. And I want to highlight again, this is the really cool part. You're going from a Cloud Spatial Anchor and just grabbing the property of that local anchor, and that is a point in the real world. So it doesn't matter whether it was created on HoloLens, iOS, or Android, you get it on whatever platform you want it on. We can then render a green sphere there, get that note that it's on a dictionary, and render it as well. And now we've completed the app. So with this, we can initialize a session, create a cloud anchor, cloud spatial anchor, and then locate that anchor. So hope this is a good starting point for you to build apps that enable you to place persistent content in the real world. But one thing I didn't show you here is how do you do wayfinding? How do these anchors that you're locating by ID actually line up with the ability to wayfind around a location? And the thing I haven't told you yet is that anchors are connected in a graph. So to illustrate that point, I'm going to walk you through a scenario. Here we have, in that box, a session. A session is basically you open up your app and you're scanning around. First, we create anchor A. So we tapped on the real world and we created an anchor. We then moved somewhere and we created anchor B. In the graph, A and B are now connected. And they're connected because we knew the location of both anchors at the same time, in the same session. If we then close that session and start a new session, so we close the app and we open the app again, if we find anchor A and B are still connected in the graph. If we then move somewhere and create anchor C, A and C will now be connected. They'll be connected because we knew the location of both of them in the real world in the same session. Now let's move somewhere else. So we walked over to that corner, and we locate anchor D. And anchor D is an anchor that we placed a month ago, and it hasn't interacted with anything since. But we're able to locate it by ID, and what happens then is C and D are connected, and A and D are connected. And they're connected again because we knew the location of all of them at the same time. So what does this mean for you when you're writing apps? Well, I showed you how to locate anchors by ID, but there's another way you can locate anchors. And that's by locating anchors connected to an anchor you have already located. So let's imagine we first locate an anchor by ID. And in that callback, we get back a cloud spatial anchor. It has that local anchor property on it. After that, we'll then create a new method, locate nearby anchors, and we'll be passed in that anchor. So that's an anchor that's been located. We'll create a new criteria called this near anchor criteria, set the source anchor of the anchor that's already been found, and then we'll go back to our anchor locate criteria, set the near anchor as that near anchor criteria, and create a watcher. Semantically, what this means is you found that cloud spatial anchor, and you want to find anchors connected to it. You can set a property, which is the radius. So you can say, find me all anchors within 2 meters, 5 meters, 10 meters. And Azure Spatial Anchors will fan out in the graph and return anchors that satisfy that property. If we go back to the diagram, let's choose D to be our source anchor. If we choose D to be our source anchor, we'll get back A and C, and we'll also get back B, because all of them are connected in the graph. If you think about this on a larger scale, say a factory floor or an amusement park, if the entire area was connected with anchors, you could start in one location and get to the other. And you can get to the other in the real world. These are real points. As an example of this, we built a demo app internally. And we're seeing here that we have a start location of the hallway chairs, and we want to get somewhere. We know where hallway chairs are, and so we can do a locate anchors by ID call there. So here we are, choosing the place we want to get to. We want to get some tea. We're going to do a locate anchors by ID call on the hallway chairs. We're going to find it. So there we go, we found it. Now we're doing a nearby query, so we're finding connected anchors, and we're able to find tea and display an arrow telling us, yeah, go that way, the tea is over there. We're then able to find it. And we made it to tea successfully. So with this extension of that app that I just showed you, I hope you can see how, by using nearby queries to fan out in the graph, you can both build persistent experiences and wayfinding experiences. So with that said, I want to move on to a third point, and it's about UX considerations. Before we jump in too much, I want to show you a GIF again that you've seen, and I want to call it something new, which is the feature points that we get are super, super important for how we're able to locate anchors. So here's us finding this really interesting lobby. We had lots of interesting feature points. If you didn't have a good area to look at, you probably wouldn't have as much success. So in the right example, where the room is all blank walls, we don't encourage you to use Azure Spatial Anchors as much there. We want you to target interesting visual features and to avoid just a blank white wall. Second point I want to talk about is considering the scenario. So when you're considering the scenario, I mean, think about who's coming after you and going to be finding your anchors. For example, are you building an app that lets you place an anchor at the top of a hiking trail, and you want someone coming from the north and the south and the east and the west to be able to find that anchor? If so, you probably want to pan around and do a 360 as you're placing the anchor, so that we've recorded environment data about the entire scene. But maybe you're not. Maybe you're designing an app for data visualization on a conference room. And in that case, is it as important that you aim at the walls or the side corners? Maybe not. Maybe it's more important that you get your users to sit down and place an anchor in a central location and maybe be sitting while they do so. Or how about if you're building an app for a museum where you want to place information on the paintings so that users can learn more about the famous painting they're seeing? In that case, maybe you just want to scan around the painting, and it's not as important that you pan at the bench behind the painting. So as an example of considering the scenario, we found there's two main ways that users find anchors. Probably many more, so I want to note, don't take this as a silver bullet. UX is hard. The first is a target scenario. And in the target scenario, you're able to show a picture when you tell the user to look for an anchor. This can be really useful because maybe you're building that museum app. You can get an admin to take a picture of the take a picture of the painting, and when the user goes, they can say, oh, I know that Rembrandt. I'll paint it. I'll point my phone right there, and I'll find the spatial anchor easily. But that doesn't always work. Oftentimes, you're in more of a room scenario, where the anchors can be anywhere around you. As an example of this, we built an escape the room experience. And in it, the anchors could be above you, below you, behind you, or in the corner. In that case, there's no interesting picture to show them because the anchors could be anywhere. So it's more important to build UX and encourage the user to pan all around them, including down and up, instead of just looking at one thing. So with that, I want to say that we're live. So we have docs up, we have samples on GitHub for all platforms, and we have lots of other resources. So the demo code from today is on GitHub. Please take a picture of this and check it out. We also have samples, docs, Stack Overflow. We would love to hear you on user voice or through that feedback email. We try to be super responsive there and are really open to working with customers. Also, check out Renee's Twitter because he has lots of really cool videos.
No, check out his Twitter.
And there's some other fun build sessions related to mixed reality that we encourage you to check out as well. So thank you.
Let's take a 360. All right. And we should actually have some time for questions. So go ahead, please step up to the microphones and ask your questions.
Awesome. And Vicente, who is an engineering lead on our team, will also be around to help answer questions and stick around after the session.
Okay, so I wanted to ask, how are you guys getting the feature points from ARK and AR Core?
So we use ARKit and AR Core for some SLAM, but then we build on top of them and do our own feature points from the camera frames you pass in.
Okay, and that's locally on the device?
Yes.
Cool.
Yeah, so when uploading an anchor point, when uploading an anchor, the feature points that travel along with that definition, are those feature points stored with that anchor only? Or are they stored in sort of a global expanding and enrichment, global mesh of feature points?
Do you want to take it?
I don't know if you understand the question.
They are stored today with the anchor that you uploaded.
With the anchor only?
Yes.
So there's no real concept at this point of the feature point cloud,
Correct. No.
in which you can query anchor points from feature points.
Yep.
That's
No.
something that you think is a roadmap item?
We do have graph expansion in the roadmap, but we haven't really tackled it yet.
Okay, but as of today, I query anchor points by a specific enumeration of anchor point IDs or other attributes like GPS location, et cetera, not
Correct.
through feature points.
Yes.
Okay, thank you.
How's the direction determined between two connected anchor points? Does it matter how far they are from each other? Like when you save one anchor point and then you save another in one session, is it keeping track of which direction I went? How does it do that?
Go.
So basically, when you place one anchor in the session, we are using the tracker from AirCore or AirKit. So the farther you are, you're more susceptible to errors. So yeah, it is recommended that if you're going to go farther alone, you might drop anchors while you're going there. So you have places for refinement as you go.
And the direction arrow that you were showing, that's basically just a straight line. You're not really taking into account.
Correct.
Okay, and that's an app-specific decision. Okay.
Correct, yes.
Thank you.
Awesome.
Any more questions? We have like 4 minutes. Yes, there's a gentleman.
Yeah, so do you have a device spec on when these could be displayed? So some of the older devices doesn't show up these properly.
So today, any AirKit enabled device or AirCore enabled device should be able to handle the SDK.
And what's the best recommendation to show, like you showed the hello world message, but typically if you have that angle, that's only it shows up. But if you have an anchor on a moving stuff, then it's difficult to get to our data, I guess.
Can you repeat the question?
Can you repeat?
Can you repeat the question? Can you get a bit close to the mic, maybe?
Yeah, so what's the best recommendation to look at or how do you know the angle at which when you're displaying some data? So I have a dashboard where I'm displaying real-time data, but most of the time it's very difficult to pull it up because people are not used to it or they're handling or fiddling with their device.
You still don't get. Let me follow up with you after because
Yeah.
I'm not sure if I understand the question.
Thank you.
Cool.
Awesome. So we'll stick.
There's another one.
Last one.
This may not be worth everybody's time, but I'm just curious as a newbie. If I maybe made an app and gave it to my kid, right, and I said, you can put dinosaurs all over the house, right, and you're going to go find your dinosaurs, is he going to be able to find those after he cleans his room, for example, and the location points change?
So within reason, yes, but like if you remodel the room, you'll probably not find them because the algorithms are actually pure visual. So you can imagine that if you go to a room and you can recognize it as a human, it's the same thing for the camera. So if you go in and the room is vastly different, you'll probably have trouble finding them.
Okay, thanks.
This is kind of related, but the feature points are very specific to lighting and to the data model that is being used at that particular time. And so Google updates theirs every, who knows, week, month, whatever. iOS will also, Apple will also do that. So how have you found, like, as you're developing this, the accuracy? Are you able to, like, as they progress and change, as the lighting changes, are you guys able to keep that point here when the lights are, 10% versus they're 100%?
So today we're like really starting on all this analysis for like how to do persistence. We are like really betting really heavily on it, but we still haven't done all the experiments. So today you basically rely on multiple anchors for different conditions, and that will be your best bet to actually get recall.
Yeah, but you might remember the video I showed, like at the Pike Place Market. It was really a different flow pattern, right? It was dry and wet, like really a different contrast for the SLAM to try find the feature points, and it worked surprisingly well. Of course, it always has limitations, right? But like the level we are at now, it's already really impressive, in fact.
So related to that, when you're the one that you showed with the showing an assembly, if it's great as long as the assembly is in the same place, but if they move that assembly, it's still the same assembly, but they move it slightly in the room because they're changing their shop floor. Do you have to then reorient everything, or does it? Are all of the feature points just located on the assembly itself?
Yeah, it really matters, during the Cloud Spatial Anchor session, what you really capture, right? If you would just focus on the automotive seat, then this is the feature points, right? And so if you don't capture a lot of the environment, the chance will be much higher that it will relocate that. But Vincente, you want to add something to that as a
So basically, the anchor post that you get back is relative to the feature points. So like he said, if you just scan that where the seat is and you are only taking that into account, like the code, even if you move it, the post will be relative to that. So it will be moving with it at that point.
All right, we're right at the end. Thanks a lot for attending.
Thank you.
Enjoy Build.